37,000 feet, an engine exploded. Seconds later, every hydraulic gauge read 0. The two wing engines still worked. The normal flight controls did not. This was United Airlines Flight 232, a DC-10 carrying 296 people on July 19, 1989. The blast came from the number 2 engine, mounted in the tail. The aircraft rolled into a descending right turn. When the captain moved the controls, nothing answered. A single engine failure had somehow reached through 3 independent hydraulic systems and disabled every conventional way to steer the airplane. The failure began long before that afternoon. Inside the engine was a titanium Stage 1 fan disc, a heavy rotating part that carried the fan blades. During manufacture in 1971, a metallurgical defect formed near the disc bore. Under repeated flights, a fatigue crack grew from that defect. By the accident, the disc had been in service for 17 years and more than 15,000 cycles. It had been removed for piece part inspection 6 times. The investigation concluded that the crack should have been detectable during previous fluorescent penetrant inspections, but it survived every opportunity to find it. On Flight 232, it finally reached critical size. The disc broke apart at enormous rotational speed. A failed fan blade is supposed to be contained by the engine case. A shattered disc is different. Its fragments carry so much energy that full containment is impractical. Protection depends on keeping vital systems separated, shielded, or outside the expected debris path. The DC-10 did have 3 independent hydraulic systems. Losing one still left the others. But in parts of the tail, all 3 sets of lines had to pass through limited space, physically close to the center engine. When the disc disintegrated, fragments crossed that shared zone. One cut hydraulic system 1, another damaged system 2, a third struck system 3, functionally separate, physically exposed. Pressure and fluid disappeared, and the airplane had no manual backup capable of moving its large control surfaces. The crew found one remaining influence: the 2 wing engines. Reducing thrust on the left engine helped roll the aircraft back toward level. More power on one side and less on the other could nudge its heading. Changing both together could affect pitch indirectly by changing speed, but this was not normal control. The DC-10 kept oscillating in pitch and roll, and every correction arrived late. An off-duty United DC-10 check airman, Dennis Fitch, came forward from the cabin. He took the throttles, while the captain, first officer, and flight engineer divided navigation, checklists, radio calls, and whatever control inputs might still help. 4 pilots were effectively trying to turn 2 engine levers into an improvised flight control system. Air traffic control guided them towards Sioux City, Iowa. The aircraft could make only rough turns, and the crew could not hold a stable speed, descent rate, or alignment. They accepted runway 22 because reaching the longer runway would have required another difficult turn. On final approach, the right wing dropped. The wingtip struck first, then the landing gear, and the aircraft broke apart as it left the runway. The National Transportation Safety Board later concluded that, with all hydraulic flight controls lost, the airplane was virtually impossible to control and could not have been successfully landed on a runway. Of the 296 people aboard, 185 survived. 111 did not. The investigation did not identify one simple fix. It exposed a chain, a hidden material defect, inspection methods vulnerable to human limitations, a rotor failure too energetic to contain, and 3 independent systems sharing one physical danger zone. Recommendations called for stronger and redundant inspection of critical rotating parts, better analysis of uncontained engine debris, improved protection and backup research for flight control systems, and changes to emergency and rescue procedures. The crew also became a lasting example of cockpit resource management, expertise shared, tasks delegated, and authority used flexibly when the checklist had no answer. Flight 232 left one lesson that reaches far beyond aviation. Redundancy is not just the number of backups on a diagram. It is whether one real failure can find the same path through all of them.